And let me add a 4 here. So this meta quiz is about the definition of F statistics, or F value, or F's test statistics. You can hear all kinds of expression about the same idea, so don't get too confused by it. So this quiz is about the relationship between ANOVA table, okay, and the how to calculate F value, and how to check the F value table. Okay, so let's quickly give you a review of what is ANOVA table. So ANOVA table will be something like this. Let me just draw a rough graph, so give you a basic idea of what's an ANOVA table. All right, so if this is an ANOVA table, okay, so of course you will get the degree of freedom. You always need to consider the degree of freedom in the field of statistics, or you will get the wrong answer or some biased answer rather than the correct answer. All right, so if you see the degree of freedom, you will know. And let me just remind you that there is degree of freedom every time we encounter statistics. Okay, so when you got the ANOVA table, you will have mainly 3 subjects for you to consider. One is, of course, the regression. The other is residual. And of course, you got the total, which is the sum of regression and residual. Okay, you got sum of that up, you got the total. And of course, you can calculate all regression, residual, total from a different perspective, of course. So let me just add all this classification, and let me just show you how to generalize this method of how to deal with an ANOVA table. Okay, so normally you got the degree of freedom, and you got the SS, which is sum square, and as the name suggests, it's the sum, so you need to add all that up, and the square, you need to square all of that. Okay, so as the name suggests, this is self-explanatory. Okay, so but this is just an intermediate result, not the final result. What we need is the mean sum of the square, which means that you got the sum of the square. You need to divide the sum of the square by this subject, by this number that you are dealing with. So you got the mean, okay? So it just give you the average of what the subject is about. So you just average that, and you got the mean sum of square. So we got the mean sum of square. And of course, once we add different subject, we got different mean sum of square. So we got mean sum of square of regression, and we got mean sum of square of residual. Sometimes we call the residual error, which is the data that we can't get. So as you know, if you can't get that, it's the error for you. Okay, so what's left is the error, and you got the mean sum square of regression. We got mean sum square of error. So you got the MSRA, MSC here. So that's pretty much how you do that. And of course, once you got the MSS of regression and residual, you can sort of just calculate F statistics directly here. So that's pretty much how you will see the ANOVA table if the test mentioned that as an exam. And there are some formula you need to memorize as well. So from the definition point of view, you got the F value, of course. Let me just. So the F value equals to, of course, one thing you need to remember that is F value is something like this. So it's just one tail. One tail means that it's really big. If you know that it's really big, you need to use the big number to divide by a small number. That's just one trick for you to memorize. who divided by who. Okay, so what is the big number here? The big number we're dealing with is the mean sum of regression, because you know that you are doing a regression analysis. The regression will be a big part, and of course the rest, the residual, as the name suggests, is a very small part of it. So we got the mean square of error here. So that is give you a generalized idea of what is going on. And of course, if you are not given MSR and MSC directly, you can use your calculation. Okay, you got the sum square of regression, SS, the regression, and you got the SSE here. And of course, you need to calculate, and you got a mean. So how to calculate the mean of SSR? You know that when it comes to regression, the very important variable we need to consider is the variable. Okay, so if you got the k variable here, we need to divide by k. And of course, when it comes to residual, which is the thing that left, if there is a total degree of freedom n, we need to subtract k, because we already used k at regression, and of course we minus 1. That's how we got the mean MSE. Okay, so that's pretty much how it is done. So once you got that, you got the f value, and f value is the test statistic. And of course, once you got the test statistics, you will check that out at the f values table. Okay, let me give you some random idea of what is the f values table. So once you got the f value, you calculate the f value, you will find the critical value at the f values table. Okay, so say that is a degree of freedom. This is a degree of freedom 1 and 2. One is at the denominator, the other is at the denominator. You can use that interchangeably. Okay, so this graph may be a degree of freedom equals to 2, this equals to 1, or is fine. Okay, so you just find your denominator's degree of freedom and denominator degree of freedom, and you just locate the exact critical value. Okay, that is critical value. Let me just use the algorithm here. So the critical value is the critical value CV, and once you got CV, you got the critical value over here. So once you got the f value, if the f value is bigger than the critical value, you can sort of nail that the f is significant. Okay, so you got the final significance test of whether it's the whole function, whole regression comes as significant as it claims to be. All right, just like we do the normal t-statistics, but just using that as the significance of f, and this one-tailed test. You always need to keep that in mind. That's how we do this f values calculation, how to do the test statistics, and how to find critical value, and how to make your judgment call, and all we find all that information from an ANOVA table. Okay.